Hello and welcome back to the Oxford MAT Livestream. What's the name of the show? I think I know what I'm doing. What an intro, there we go. Flawless as always. You're watching the show from Oxford where we go through past maths questions in preparation for the mathematics admissions test. I'm joined live by some people in chat. Who's in chat today? Good morning, Ruben, and hello, Neil. Are in chat. You could be in chat as well if you're watching live. You can join at slido.com/MATLIVE, I think, or if you go to slido.com and put in event code MATLIVE, then you should find us, which is what Jacob's done, because Jacob says good afternoon as well. Hello over there. Right, good. You'll notice on screen I have 2016, 2017, 2018 past papers, and also 2015, because last week I kind of lost count. That's my excuse. I kind of lost count and forgot to do any 2015 questions until the last 5 minutes. We are going to do several rounds of voting. You know I like a good vote. Hello to Anonymous, by the way, and somebody who's put their username as finally chose a name, which is an excellent reminder that you can be anonymous or you can be anonymous asterisk, where you anonymous with a name, confusingly. I always like to know how people's day is going at the start of one of these, so here's a quick vote for them. I hope they like voting in the live Slido lobby, because I need to select a question from so many questions on the screen this time round. Straight away there's someone having a terrible day, which I think there's 2.5 there for a moment, which is like 1 and a 4, which is not a good combination. We'll see how that settles out in a second. I think, yeah, unreasonably high percentage of terrible days, which is not what I want. But now 4 stars and 5 stars kind of taking over. Oh, great! I love these things. Sort of live updating charts or whatever. You could watch that for an entire 2 hours. Hi to Anonymous in chat. He says, I was wondering if on the question answers for the long questions, how do we type things like powers? I don't know. And could we get penalised for not using correct notation? That's not the idea. So the guidance, once again, is that for the long questions where you're typing answers, 25, you get a standard keyboard, and the people who wrote the questions knew that candidates should have a standard keyboard. It is not supposed to be a notation typesetting. Can you do weird stuff using a standard keyboard? It's, when we get to 2024, we will see some examples of questions where you can just do these using a standard keyboard. Right, okay. I can never have a 5-star day, says finally chosen name, so that's kind of sad. And I've been reminded that I should apologise for everybody who subscribes to this channel who will have got 19 videos. I hope you didn't get 19 notifications. If you have made the mistake of clicking the bell for notifications on this YouTube channel, of all YouTube channels, then you'll have got notifications for all of my lecture course. My first year lecture course has been uploaded to this channel as well, so I'm super excited. I guess that's probably the people about 1 year ahead of, anyway, never mind. That's the thing that I've been up to recently. Somebody in chat did get lots of notifications. I'm sort of excited but also terrified, and mostly I'm sorry, but I am grinning. Right, okay, so chat's worked out as kind of a 3.9 kind of day, which is not great. Oh, 4, stop counting, there we go. That's awesome, there you go. Yes, so somebody got 19 notifications. Right, sorry, I did go click all the way through them, there you go. Didn't realise the effect that would have on your phone. Right, there was questions in there about international students generally required. We don't have a pass mark, so what am I saying? Generally, the international students who apply to Oxford tend to be quite good. I don't know what a global average would be if everybody on the planet had to do maths. I don't really want to think about that. That would be a terrifying proposition, really. And Ruben asked in the middle there, do Oxford admissions dislike it when you switch schools midway through A-levels? No, I don't see why we would dislike that. If that happens, I'd assume it was happening for a reason. Not sure I would dare to have an opinion, my goodness. Mostly we care about study and you. when we admit a student, we don't get to admit any of their teachers or schools or referees along with them. We just get the student. So if the student has been at a different school every year, then it's still just one student we're admitting. And that you're a product of so many factors and so many people and so many influences, but at the end, we're admitting a student. Can we invoke a theorem or technique to help answer an explain question? Yeah, they're sort of designed so that that's not really... The point of the questions is not really, have you heard of this weird theorem? If so, type its name in this box and now you're done. That's not really the style of what we're going for, but you go for it if you like. There's a free text box, you can type whatever you like, really. Some of the recursive proof by induction. Yeah, if you're going to say by induction, you know, for example, for proof by induction, just reading that chat comment, you know that to do a proof by induction, you have to do several things. And it's possible that if you've spotted a question, what you're really noticing is that you have to do several things, and all candidates have to do several things. How much working out should you really be putting for longer questions? When we get to 24, you'll see some examples of what that interaction is like. I think what's the guidance I put on the website? Has it got the word working out on? Sorry to stick on this point, but I can tell that chat is a bit worried about it. I want to try and find my reassuring text that I wrote last year. Yeah, what was my reassuring text? He says, less certainly. Candidates are not expected to type complex mathematical expressions or use any symbols beyond those included on a standard keyboard. As with long math questions from previous years, candidates should expect to justify their answers or explain their reasoning for these long questions. There you go. That's what we've told people about the long questions. Good. Okay. And then just a couple more quickly before I switch on another vote. Will I be allowed to drop my 4th A-level if got an offer? Offers are technically legally binding. If the offer says that you only have to do 3 grades, then you only have to do 3 grades. If the offer says and don't drop your 4th A-level, then don't drop your 4th A-level. But read your offer text carefully to find out whether there are extra conditions or not. Extra MCQs. Harder than the... there are some extra multiple choice questions. I think at the top there, I think you mean the ones where it's just a test that's just multiple choice questions. Those often are a bit tough, but I don't know. It's all a bit subjective, isn't it? All right, 5C3. Yeah, I think the mark is probably not what 5C3 is. Sorry, I've got quite a bit of a chat backlog now. Aaron, you can ask. It's on the MAT website. It's not a secret. And there's a practice test on the website where you can do a practice test. It's really we're trying to tell everyone. Right, okay, and we've also got Oxford admissions doing. Oh my god, right, okay. I'm going to turn the vote for which past paper we're doing, but then I'm going to keep reading out some chat because there's a little bit. 4th A-level, unrelated to maths, fine, whatever. Don't need you to do a 4th A-level. Don't need it to be on maths. My goodness. Can we look at ECAA 2021 question 30? No, sorry, it's a MAT Livestream. What does variation look like? So somebody's asked about variation, which means that they've seen the average scores in my table of past papers on the MAT page with the coffee cup. They've asked about variation, so I need to tell them to click on the feedback for the admissions round, which includes a histogram, so you can see some distributions. There are some working out marks. And then, just while we're voting on which paper to look at, how do you deal with exam stress? Says a user who's put their username in as I'm just me, which is nice. Personally, I switch questions, which is good because it gets me to do other things rather than staying still. And if I'm successful on a different question, then I get my confidence back a bit. But I've had exams where that's also not great behaviour because I end up switching and not getting as much done. I suppose I've interpreted that question, how do you deal with exam stress, as if it's literally me, when I suspect maybe the person is asking for literally them. And I suppose my message is to you, I don't know you, but I suppose my message is I try and remember that you're good at maths, and with time you don't know what your brain's going to come up with. It's okay to not answer the question straight away. In fact, that's kind of the intention on some of them, that people won't be answering them straight away. Oh, I'm glad somebody's finding it relaxing. I don't know if I'm finding it relaxing. There we go. What was the level of 24/24 MAT multiple choice questions compared to the practice test available on the website? I think no comment, probably. We don't really assess level between different past papers. We don't care because we're not assessing. Those are different tests taken almost entirely by different people for different admissions rounds. Yeah, okay, good, right. That's a bit flippant of me to say we don't care. Like, we try and get the average score about the same every year by setting questions that we think are about the same difficulty as the previous year. But in some sense, it doesn't matter to you either, in a way that if all the questions this year are a little bit harder than last year, then that's fine. It's not like it's not like an A-level grade where it's a qualification that you'll carry with you throughout life or something. It's a comparison against other people applying in the same year for places at Oxford. And we've got places at Oxford, so we got to admit some people. Right, okay, let's stop the vote because 2018 has won. That's not why we're stopping the vote, which is interesting to me anyway. Should we do a multiple choice question? I feel like we should do one just to get going. Let's have a go at one of them. If you would like to see them, well, you can get them on the past papers website, of course, which is also your one-stop website for... What else is on there? Average scores, solutions, flashcards, the feedback document I just showed people. I've completely forgotten what's on my own website. What a weird effect. We've got questions on integration. We've got all differential equation alert. Why is there a big vote for 1A so far? Okay. Areas and regions. 1B is the first MAT question I ever wrote. Hey, we've caught up with the year when I started working in Oxford. Hooray! It's not about me. I'm interpreting everything as about me right now. That's not healthy, is it? There's circles. There's this weird question about triangles S and T in a circle. Although if you remember that question we looked at before, where there were 3 points on a circle, and part of the punchline was, ooh, you can move a point around. Hey, never mind. There's something about maximising areas or something. It's not quite maximising areas this time around. It's not literally the same question. It kind of rhymes in a way. And there's some cross sketching. Good. And then there's some long questions that we'll look at in a second. H is winning that vote, I think, and it's not as close as I thought it was going to be. And then somebody wants to look at 2023. I think we're going to get to 2023. Oh, and you think there's a particular suggestion? I will note your particular. I will note that someone says that one solution for a different year, a different paper. Solution unhelpful, and it's a solution that I wrote, so yeah. Yeah. Okay, I'm going to get ready to do 1H, I think. Oh, which is also the one in the thumbnail, so well done chat. You voted to make sure the thumbnail is not clickbait, which is something I aspire to. Just to do the interview question really quickly, and I don't want to talk about interviews too much because, well, sequentially we do MAT before interviews, so the interviews are coming up afterwards. We have a live stream in the future dedicated to interviews, but just quickly, interviews for Oxford are online. The normal way we're doing that involves Miro whiteboard, but we have some efforts to try and help people make that work. I would not stress about online whiteboards for interviews. We've got quite a lot of experience of doing online interviews. We have lots of backup options. We've been doing online interviews for about 20 years because we've been doing them for overseas candidates for ages. So please don't stress, we're not new to this. It's similar to that circle triangle question that we've done before, isn't it? Right, I'm just going to hide chat so I get more writing space. Here we go. I think I need to zoom in a little bit, don't I? I hadn't full screened. There we go, and then it pops in all of there's the quality. The quality. Right, here we go. Okay, so chat's voted for this question out of all of the questions in the world. Out of all of the short questions in the world, I suppose. I didn't know they were voting for short questions to start off with, but here we are. Triangles S and T are inscribed in a circle, shown in the diagram, and the triangles have respective areas S and T, where S is the smaller triangle so that S is less than T. Okay, and then we're asked for the smallest value that this expression can take. And there's 5 possibilities for what that might be. So this is a bit odd on the face of it. We have the bit up here that's definitely geometry, and we have this bit down here that's kind of algebra, and we have some inequalities going on all at once. And when we did revision for the MAT Livestream before, those were all separate topics, and obviously questions like to combine topics together to make things like this, where you see a bit of everything. It's worth exploring, I think, when I mean something like this, you know, sort of what's possible, right? For example, if I know T, if I know T, so if I know T, the area of this triangle, do I know S? And perhaps I'm biased a little bit by having thought about that previous question. I guess it was a couple of weeks ago on the show. We had a triangle and a circle where one thing we thought about was moving a point around, so different possibilities. Well, it's still true here that we can think about different possibilities, right? S could be like it's drawn in the diagram, or I suppose S could be something like this, where this triangle might involve a point over here. I'm imagining moving that point round to be really close. I'm interested in these kind of limiting cases, also what's going on in between, and I think, well, I can make S really small. No, S could be really small. That's first observation. Whatever T is, S could be really tiny if I make this triangle a really thin little wedge by taking the other point really close to one of the points on triangle T. Triangle with area T? Triangle called T, lowercase t. We could split it up, but I suppose we haven't really understood what the question is yet about what are we trying to work out, right? Because maybe the reason you're splitting it up, sorry, in chat someone wants to split it into 3. Maybe the reason you're trying to split it up is to try and work out the area. Can we work out S and T, lowercase s and t, sorry. And that seems a bit doomed because there's not enough information. At the moment, it feels to me like S and T could be anything, right? Like, there's a whole picture here with circles and triangles, but this doesn't tell me what S and T are. It's not like, and this is experience of having seen other questions, right? It's not like they told me that T is an equilateral triangle and S is a right-angled triangle or something brilliant. They didn't tell us anything, right? As shown in the diagram, but well, that could be anything, couldn't it? And then I realised that it's not quite anything, because I can make S really small, but I'm not allowed to make S very big. I suppose in this picture I'm thinking about that because, well, this looks about the largest that S could be in this picture, but even if T was different, I'd still be limited on how large I could make S. In fact, I'd be limited by rereading the question and seeing this, right? So dot here, but not arbitrarily large. Apparently S is the smaller triangle. So at the moment, I think this picture could be any size. I've got no idea how big these triangles are. And it feels like a T could be absolutely anything. And then S, I reckon it could be anything from 0 to T. So this is kind of my impression that all of this stuff about circles and triangles, and all I'm getting from it is just that's it from the circles and triangles. And I can probably make that formal. I can probably think of examples where you tell me areas S and T, and then I go and work out some triangles to fit it all together. But yeah, And Anonymous has read further in the question to find out that the thing we're trying to minimize, this function down here, is not just anything. There's a trick you can do to divide top and bottom by t squared. This is a good trick. Well, first let's check that it's a good trick. So if you divide top and bottom by t squared, then, well, this is a good trick because now the top and the bottom only involve s over t. Separate question, how on earth did you think of that, Anonymous? So Anonymous in chat wants to divide by t squared, top and bottom, to get this as a function of s over t, to which I'll let them answer, but it's probably something like you realise that both of these look a bit like quadratics. The top one really feels like a quadratic in S, and then I suppose the lower one doesn't feel like a quadratic in S. But now I've got the idea that I'm dividing some polynomials. So maybe I want to try and make that look more like a polynomial, where it might have a number on the end. Maybe that's my inspiration for dividing by t squared. Just sort of see, you know, well, I've got t squared, I've got two things multiplied together down here. In general, if you've got terms like s squared, st, and t squared, then those are all kind of, well, they're pairs of letters multiplied together, aren't they? st, s times s, t times t. They all have something in common, which is kind of good. Yeah, okay. So, question Anonymous in chat, is there no way to do this geometrically? I think there is no way to do this geometrically, because I think the geometric picture contains almost no information. So it's a bit like if the question just said there are functions f and g, and the integral from 0 to 1 of f is s, and the integral from 0 to 1 of g is t, with s less than t, then there's no way to do this question with integration because you're never going to work out the functions f and g. There's just not enough information to go all the way back to work out precisely what the functions were or precisely what the triangles were. So I think it's not really a geometry question at all, despite having a big diagram in the middle. That's annoying, isn't it? What's s over t then? So where have we got to? We've got to here, and we want to understand this, which inspires me, I think, to rewrite this as saying s over t would be between 0 and 1. S over t would be between 0 and 1. And then I'm in good position now. I'm going to call it u or something. That's the next letter of the alphabet, isn't it? And now everything's coming together because I have 4u squared plus 1 over 5u. And my task, I think, is just to minimize that with u between 0 and 1. So I could try and sketch this. I could try and differentiate it, for which I think, what's this 5 doing out here? Anyway, never mind. I think I could write it as like 1 over u, like divide each term by u, splitting the fraction apart into two terms. I think I could differentiate that. It's just messing around, really, isn't it? So that and differentiate. Whoa. Zoom. I think this is the function. I think this is the function we've got, and I think it rearranges to this. That's a 5. That's a u, and then we can differentiate it. And then I think it'll fall over from there. Yeah. So expand and simplify, differentiate. Start turning the handle for here's a funny function. Can we find the place where it's minimized? And I reckon we probably can. Can I do that? Maybe not in my head. It looks maybe like u is a halfway in between. Sounds about right. At which point the value is 1 plus 1 over 5 over 2, so like 2/5. No, 4/5. I think. Chat can tell me whether or not. Yeah. So chat. Throw it back in again. There you go. Rosie in chat says the picture is not needed. It helps to visualize, although I'm not sure what it's helping us to visualize. Oh, hello. My whiteboard just said connection lost, and then it said connection restored. I don't know if that also means that YouTube lost the connection, restored it again. I wonder if that's an Office thing or a whiteboard thing. Yeah, okay. I've got 4/5 in the end, but I did accelerate through the algebra at the end, right? on a scrap of paper over here. I've got this, and then I've got u is 1/2. I'm being a bit sloppy with my plus or minus square roots. Oh my goodness, the letter u is very hard for me to draw today. There we go, u is 1/2, and then plug it back in, so like 1 + 1 over 5/2. I think I'm good. I did the work. I also have, I don't know why, but I switched to a scrap of paper, which is very rude of me because you can't see my scrap of paper. I was just aware I was getting quite scrappy in this corner, right? So differentiate the thing inside the brackets goes to, so okay, let's call it y equals this, then do y du. That's where I feel like picking x would have been more clever because I'd be more happy. Same effect, just this, which is 0. And then solve this bracket equal to 0 at u is 1/2. When y, and then I've got to plug it back in. Oh no. 5 times 5 times 1/2. I'm trying to plug in, u is the value of s over t, so I'm trying to plug it back in. I can't tell if this is annoying or not, but the thing I'm trying to do with the pen is point at what I'm looking at. I realise that might be annoying because maybe you're trying to look at it as well and then the pen's in the way. I realised after I'd recorded 8 hours of lecture videos that I do that constantly. Watching the footage back, I realised that I'm always pointing at the thing that you're supposed to look at, so then the pen's in the way. Sorry about that. I'll try and correct that. Is there a method that uses the picture? I think there is not a method that uses the picture. There is maybe magic. Pen's helpful, okay. You could put that function in Desmos, that is a good idea. So I'm going to let people do that. I don't know what stationery you're allowed to bring to the exam because I haven't recently read the rules for Pearson VUE. I don't think you're allowed to bring any stationery actually. It's possible that you're not allowed to bring any stationery. I really don't think you need any stationery. Yeah, I can't think what stationery you would be able to use really. Yeah. Thanks. Someone in chat says you're not allowed to bring anything, which, you know, anonymous on the internet, but I'm going to believe them. Okay. What a weird question, right? It's got this big circle in, which people in chat seem quite certain that they would like to use the fact that the circle is there and it is round. But I think if you say ellipse or rectangle, then I think it's the same answer. I don't think it's a fact about circles at all. That's annoying, isn't it? Right, Rosie agrees as well. You get given a pen to use. You get given a pen and a special sort of whiteboard to use in the exam room. You don't get to bring your own diary. Sorry. I say this sadly as someone who is very attached to using pencils, and it's not pencils in the exam room. Right, okay. Good, let's vote again. I like voting. I think it's time for a long question, so I'm going to switch on the long question. We're going to stick on 2018 because I think people might have voted for 2018 for the long questions. We'll find out. Look at that speedy vote for some computer science. I'm going to quickly check. Yeah, I think I'm fine. Kind of fits on one page. Sneaky check. Right, okay. Chat is voting. I'm going to quickly read. Do they got any questions? Do they got any questions? I think we're good. Do we get Desmos in the exam, says Neil? Probably not seriously. I don't know, maybe it's serious. No, sorry, you don't get a calculator, you don't get Desmos. Maybe that is serious because they've heard that it's online. It's in control conditions though. Yeah, okay. Right, okay, we're voting. Question 7 is currently winning. I don't think we've done a question 7 yet on the live stream this year. Shall I start zooming? Oh, it's in a fight with question 4. The rule back in the day, back in 2018, was that question 7, was just for applicants in computer science or computer science and philosophy, and question 4 was just for applicants for maths and stats, maths, philosophy. So nobody that year did both questions 4 and question 7, and chat is currently voting to decide which one we're doing. Oh, question 6 has joined in as well. Question 6 was for people doing maths and computer science who did neither 4 nor 7, so we got some real some real choosing. Oh, this is also the one. This was the question that just you realise it has like an English language typo in it, right? Maybe I should fix this on the website so that I don't have the past paper. I have to edit the past paper. Maybe that's disingenuous after 7 years. Just accept that there was a vote. There was a thing. An exam where you're allowed both Desmos and Wolfram Alpha would be very cool. Do I know of such an exam? Not really, but during my PhD I was allowed access to all of this stuff, right? And then I guess there was a Viva at the end, but during PhD I was allowed to use a lot of tech. In some sense, like working mathematicians are allowed to use calculators or things that are better than calculators, like Wolfram Mathematica is pretty good. There's specialist software for some fields of mathematics where people just like put in a group theory problem and it just gives you the answer. So in some sense there's a little bit like it's a little bit like when small children learn to multiply and they say, well, my calculator can do this, right? So it's sort of like that. Calculators are getting really good at a lot of different things. After MAT you get 3 interviews from Oxford. We don't guarantee that anybody gets exactly 3 interviews. That would be a normal number of interviews, and it doesn't matter whether you chose a college or go. And then they put random pool, by which I think they mean open application, and they need to hear the message that if you make an open application, then you just get assigned to a college and treated exactly as if you applied to that college. I think some people mistake it for a kind of multi-select, that if you choose open application then maybe you will go to some sort of departmental pool or you'll be shown to all of that. It's just, you get given a college and then treated like you're at that college. You think Desmos might be allowed in SAT? That'd be exciting. Can we use graphical calculators in university maths? I think all of our exams for the maths degree are non-calculator. I think that's true. Yeah, I think I'm going to stick with that. I'm happy saying that on the internet. I think that every maths exam in the undergraduate degree course, no, I'm going to wimp out of every. I think almost every. Ooh, yeah. Yeah, so then the obvious follow-up question is it better to have an open application or pick a college? It doesn't matter. If you make an open application, we will tick one of the boxes for you, and then you'll be treated as if you picked that college. It's an option there if you don't care. If you don't care, if you don't want to choose from the list, we will choose for you. But it doesn't give you any special privileges or disadvantages or interesting steps of admissions process. We just choose one for you. If you got full marks on the MAT, but only just meet the... Hang on. If you get full marks on the MAT and you meet the minimum requirements for uni, carry on. That sounds great. Sounds really good. They say only just meet the minimum requirements, but for us, the minimum requirements for A-level students is like A star, A star, A. So that's definitely enough. You don't secretly need 3 A stars or something. Why would you ever? Yeah. Right. Okay. 4 and 6 are locked in some sort of tie, so I kind of need either somebody to vote or maybe I just choose. 6 is the Egyptian fractions question. 6 is the Egyptian fractions question, which is fine. If you know about Egyptian fractions, then maybe you've seen some of these calculations before. If not, then hey, we can learn about Egyptian fractions. 4, I sort of see why people are voting for it. It's got a really difficult diagram. When I started in 2018, I kind of wanted to change this diagram, but there was quite a lot of risk of just being some guy who's just turned up, only just started his job, and ruins question 4 on the MAT by deleting the diagram or something silly. I don't know, I think these days I would have 2 diagrams or something. Maybe I'll show you how I'll split that up. Question 4 is now winning. Right, okay, I think we're doing 4. I think it's happening. What happens when you pick a college but there is no more available seats? Well, we treat everyone in a gathered field, right? So we wait until we've got all of the applications, and then yeah, you're right, there are more applications than places. So we run an admissions process to decide out of everyone, it's not first come first served or something, out of everyone who applied, we choose who we want on the course. And it is very normal for there to be more applications than places at every college and overall. Does it help me because I don't know what colleges to apply to? It helps because instead of choosing one college, which is all that you can do, you can instead tick that box, and then a computer algorithm doesn't run on literally that computer, but I am pointing at my computer, will decide for you. So it will help in that sense, that you won't have to choose between Wadham or Worcester or New College or Balliol or one of the others. Right, okay. It's a fun diagram. It's a fun diagram. It's a fun diagram. I mean, everyone's entitled to their opinions, aren't they? This is that. Everyone's entitled to their opinions. Right, okay. Here are two circles. Let's see. Two circles, S1 and S2, which with centres A and B, and they've got radio, oh my goodness, root 6 and root 3 minus 1. Oh gosh, I think so. It's C and D, and they're a distance 2 apart. So that's quite good. That tells us enough so far that we could redraw the circles if we had to. Something that I try and play along with in my head is to try and work out, can I tell what this picture is? And if you tell me the distance between A and B and the radii for those circles, then I think that's enough to redraw it. I guess I might draw it wonky or at an angle or something. I might forget if it's left or right, but I can make you two circles of those sizes, I think. I suppose I'm going to have to work out how big root 6 is, and now I've become worried about whether root 6 is constructible over the right. Never mind, okay, yeah, I can do that, I reckon. It's enough to redraw the picture. If I have very accurate rulers or something. You don't get a very accurate ruler in this example. And never mind, we're not drawing it, it's right there. And then we're going to read part by part. So in part I, it says find the angle CBA, which is irritatingly not drawn. So the first thing I have to do is draw in the line BC, right? And I want this angle here. And crucially, most of the picture doesn't matter for that, right? There's all this shaded region, the circles have got special names, there's this dotted line from E to C, there's a dotted line from C to D as well, there's the point D. But most of that doesn't matter, because all I need for the angle CBA is, well, facts about CBA, right? Let's try and get, oh, that's a terrible picture of a triangle. Let's try again. Try and get 3 sides on my triangle. What I need is, well, I actually know all 3 lengths, all 3 sides of this triangle. None of them, well, I guess the 2 is in the picture, but 2 of them are not really in the picture. The line BC wasn't there, I had to draw it in, and then I had to remember that it's the same length as BD, that's the radius. And this root 6 along the top wasn't there, I had to label it, remembering it's the same as AE. But now we've got this question about finding an angle in a triangle. Well, that's fine, isn't it? Okay. Ooh, Neil, quick intervention. Neil is looking at a bit of a website which says choose 5 colleges. Neil, I think you're looking at graduate applications, which either means that you're applying for a graduate course and you don't need any of this MAT stuff, or it means you're on the graduate bit of the website and you should be on the undergraduate bit of the website. Depends if you're applying to do a first degree or applying to do a master's separately. Yeah, cosine rule, says Rosie. I agree, cosine rule. Oh, no, I agree. Thank you, finally chose your name. You gave my job. They're referring to uni as college and getting mixed up. This is excellent chat work. Good job. Yeah. So you get 5 universities, and then within the University of Oxford, you can, I think it's labelled campus or something, you can choose an Oxford college. We're weird. We say that we're a university made of 30 or so colleges. That is a bit weird. So every time I say college, I mean one of the Oxford colleges within the University of Oxford. Thank you, finally chose a name for... I'm kind of identifying the question behind the question. Well done. Good, okay. Let us know if that was correct, Neil. If not, sorry for answering a thing. You are the other, yeah, okay, Neil, I think Neil's correct. Yeah, good. Okay. Love it when chat helps each other. Or helps me do my job. Okay, I think if you do cosine rule, then you get 120 degrees. And that's from memory, not from me doing the cosine rule in my head. Oh my goodness, let's quickly check. 6, 4, root 3 minus 1 squared minus 2b c cos theta. That's how the cosine rule works, isn't it? And then what do I get? So 2, oh no, so 8, take away the minus 2, oh gosh, minus 2 plus 2 root 3. I'm going way too fast here, definitely going to make a mistake. Yeah, this is working out though, I think. So I've got minus 4 over here, divide by minus 4. Oh, I don't enjoy this. Divide by root 3 minus 1. Yeah, because this is a multiple of root 3 minus 1 on the left as well. It's 2 times root 3 minus 1, so I'm going to get minus 1 half. Oh my goodness, I think I've got to 120 degrees. Didn't enjoy that on a little... Why did I start so close? Why did I start so low down, near to some writing? That's terrible. Terrible sequence of plays. Okay. But we're gonna do this one step at a time, right? He says, trying to regain what's going on in the question. So A and B lie on the same side of line CD. That's just because that angle is larger than 90 degrees. So C is to the right of B as you read across, like in the picture. They ask us about CD. I think we get a choice here, because maybe when you see CD as the thing that's being requested, should I change colour for that? Maybe when you see CD as the thing that's requested, maybe your instinct is to split that in two. We just had great success looking at the top half of this picture. Maybe we want to keep looking at the top half of this picture, or maybe your instinct is to think about this whole triangle. It's part of a big triangle, and to think about that angle, because we just found an angle. So let's continue thinking about angles. And it's your choice whether you want to continue thinking about top half of the picture or continue thinking about angles, or I don't know, do something different entirely. Can I think of a third way of doing that? I'm not sure I can. Yeah, so there's an isosceles triangle, and in particular, you know the length CB. You still know the length CB. It's not marked in the picture. There wasn't a line CB in the picture, but you know that length, and you now know I'm going to go for top half strategy. You now know this angle, so you can definitely work out that side over there. I guess I am using this fact. Who's this in chat? Rob says that there's an isosceles triangle. Yeah, you can look at it. Could compare with CAD, but I think I prefer just going for it because we know loads of stuff. Could you use the triangle ADC? Oh, actually, several people. Ruben also wants to use ADC. Could CD refer to the arc? I suppose maybe. If so, we'd have to say which arc, wouldn't we? And then you'd say it's even more ambiguous because there's multiple arcs to go from C to D. I think you've in doubt line. That's a new one for me. Let's write it down on the list of line segment CD, not arc. Put it on the list. Yeah, okay, so I like this right angle triangle approach, I think, because I know some relationship between lengths of sides. He says stalling for time because I need to remember how cosine works. No, I need to remember how sine works. Opposite over hypotenuse, root 3 over 2, so I get this factor of 3 minus root 3 all over 2 for the length on this side over here. You probably did that faster than me. Probably did it more accurately than me as well. Anyway, I've got that over 2, and then the length of CD overall. I'm not going to give this point a name, but like that one in the middle there. So CD overall, well, it is twice as long. Good, okay. Yeah, I guess I'm assuming, or not assuming, but I'm going quite quickly over the fact that continuing the line AB continues to split this picture in two. As above, so below, that it's got this up-down symmetry. I'm ignoring the stuff about E down there at the moment. As above, so below, because the top half of a circle looks the same as the bottom half of a circle. So I'm being a bit slapdash with saying why. I haven't written it down anywhere on the screen at all. For example, I haven't said why that is halfway across CD, this blob in the middle there, come on. Picture's got symmetry. Why not just do cosine and show that AB is less than AC? For which part? Oh, AB is less than AC. Is that good? Yeah, I guess, are you showing that A and B are on the same side of the line CD, maybe, Rob? Anyway, okay. Yeah, I think that works. My approach is just to say 120 is bigger than 90. Which I think is enough. Okay, here we go. Here's the kind of meaty part of this, and maybe why people have requested that we talk about this question. We're asked about the area lying inside circle S2 and outside of circle S1. The shaded region in the picture, and there's a horrible number for that area. Right, so this question is assuming, I think, that at some point in your life you have answered a question like this. Circle, straight line, shaded area on the right hand side. Because, well, I know you've tried one of these because I put it on the revision worksheets, and before the summer break we had a look at things like this, where the whole idea was to use a sector minus a triangle, to have a slice of the circle like a pizza, joined centre, but then subtract off this triangle bit, because that stays there, to just give you this shaded area on the right hand side. We did a couple of those in the geometry worksheet. I think it's just a sort of normal thing to ask about circles and lines and areas that you can work out by combining together in a pretty standard way the sector thing and a triangle fact. The reason this question is hard is that it's combining together two of those. So that fact itself is made of two areas, right? Because it's the sector minus a triangle is the shaded bit. And then the one in the actual question is, I think, the chunk of a circle to the right of that line, thinking about S2, the small circle, is that area minus this chunk of a circle to the right of the line, thinking about S1. So I have two cases of the stuff to the right of a line inside a circle, and I'm looking at the difference between those. It's definitely on the right of the line CD, and if I look in circle S2, I get all of this. And if I look in circle S1 to the right of the line CD, I get this. So I'm kind of using that fact that we've met before twice. That's the idea. And then actually working it out is not too bad. He says, because we know basically everything to know at this point, don't we? So for example, in circle S2, the really important thing is that angle marked in purple here, to tell me how much of the circle I'm looking at, because that's enough to work out the area of the sector. I got it right the first time, and it's enough to tell me the area of the triangle. I suppose I need to know the radius as well, but we know both the radii in this diagram. So it's that angle there. I guess the other thing I'd like to know is the angle at A. But, well, we're doing a good job of finding angles and stuff, aren't we? So I'm optimistic that we can find the angle at A as well by marking this big one here. So that I have, looking from A, I have a chunk of circle and a triangle. I'm just optimistic we can find those things because, I guess, mostly because we know sort of where everything is. We know the height here. We know the x displacement. I haven't used the cosine thing over here to find that this is really 3 minus 1 over 2. But I could. And then I could add 2 to that to work out that distance. I could do a lot of angles, couldn't I? Is there a better way? So finding the angle at A. So I want angle CAD. Any suggestions in chat of how I could find the angle CAD? Oh no, there's a question in chat. How would you get the angle CAD? Oh, and Rob's also answered it. That was a perfect moment to turn on chat again. How do you get the angle CAD? Oh, you cosine, you have all 3 lengths. That's better than what I was saying. Okay, quick breather for me because I've said something a bit silly, which is, it would work. It would work. You know where the positions are. You know where stuff is relative to each other, right? So in my head, I'm imagining this picture, and I'm thinking about this angle in here, And my approach was going to be a little bit silly. It was going to be find, so B is in here, find the distance from A to that point by adding. Oh, I know the distance up to here, so use some sort of tan to find the angle back at A and then double it. I wasn't looking forward to doing that, which is why I asked the question to chat. And chat came in. Aha! I hoped chat would say something like this as well. Is it twice the angle CAB? This feels like a kind of circle theorem as well. Why is that? Why would it be twice the angle CAB? Oh no, it definitely is twice the angle CAB. Why is my question is, why is the angle CAB easy? I don't know. Well, I just outlined a terrible way to find the angle CAB, but I'm interested to see if chat's got a better way to find CAB. So CAB from here down to A and out to B. Good way to find that. I suppose we know all the side lengths, he says again. Anything good? I haven't really thought about this triangle up here. AC. I'm going to name it X. I don't love naming new things unless I have to, but see, you can in a geometry problem you can label so many things, right? You can draw in a line, and it will intersect maybe 3 other lines. So you could name all of those points, but I prefer to name things if I'm doing something with them. I should have named it back then when I was doing something with it, but hey. Is this good? Or even just go straight for the angle? I don't know if I can do that. Yeah, I don't think I can. That's unfortunate. I was really hoping that would be some sort of inverse sine thing where I would do the ratio and it would be miraculously one of the ones I know. But it's really not, is it? Oh, right, okay, yeah, so sine rule instead. Oh, chat's got loads of ideas today. Sine rule on the ABC triangle. Forget X. Sine rule on the ABC triangle. Chat's on fire. This is great stuff. Because it's got a good angle of 120 here, opposite a side of root 6. And you know that this is root 3 minus 1. So you know the side opposite. You know all the sides. You know the side opposite the angle you want. So what's that then? Sine of, I'm going to call this, I've used theta, so I'm going to use phi next. Sine of phi over root 3 minus 1 is sine of 120 over root 6. Is that good? I feel like this is going to give me the same problem, isn't it? I think this triangle has got an awkward angle where I won't recognise the thing down here. Okay, we're just going to quickly multiply this up. Sine 120 is sine 60, which is root 3 over 2. Goodness me, I'm rusty on those. That's what I'm learning. Yeah, so I don't know what that angle is. But if I go for AC, I'm drawing so many triangles. Quick note, I'm drawing a lot of triangles because I'm trying a lot of different approaches. I think probably in an exam I would just go for, well, I think I would do that one first and sort of get nowhere because I can't identify the angle. So then I would stop trying to find that angle and I would try and find this large angle, which seems a bit safer. Okay, so I'm going to try cosine rule over there. There's a vote in chat. Cosine, yeah. Interesting. Let's go in here. Oh, if they worked out ACB and then use the angle sum to 180, that is good. I like that. So I guess this is 2 phi if I'm being consistent, but I think I'm imagining that I'm doing this without having tried the previous method. I don't have any more letters. I'm going to call it alpha. 2, 8b, beta. What have I done? 6 equals opposite side. I've also written underneath chat. Sorry, chat. That looks a bit more promising, doesn't it? Root 6. The pen's so thick now, but I'm getting away with a lot of stuff, I think. Maybe I'm not. So 12 in here and 12 over there. So minus 12 cos alpha is minus 6 root 3. That seems okay, because then cos alpha is something nice, like root 3 over 2. So alpha is something really nice, like 30 degrees. So that explains why I couldn't recognize this one, because I think it might be the case that sine of 15 degrees might be this. I think the answer for phi might be 15 degrees. How am I going to check that fact? Oh my goodness, there's a very nice thing there. Oh my goodness. Oh, I don't like this. Am I up by 2 or a factor of 2 or something? Possibly I'm out by a factor of root 2 or something somewhere. Oh yeah, I didn't get the root 2 down here. Yeah, because it was root 2. Oh yeah, that's rubbish, isn't it? I don't like that at all. Possibly still missing a 2 root 2. Yeah. Cool. Having a great time over there. Wrote down something that isn't true. Yeah, okay. Wrote down something that isn't true, wrote 2 question marks. Even if I'd written the correct number, wouldn't have been able to work out the angle. Okay. Don't love that about the question, actually, in hindsight. The fact that it's 30 degrees, which is recognisable if you're looking at that angle, but not recognisable if you're looking at half that angle. It's not a strength of the question, is it? The last part's kind of weird. It's separate. The last part ignores most of that and talks about this point E moving around the outside, and the intersection denotes the angle CAE. You're asked for some areas. You're asked to make 2 areas equal, which involves calculating some areas, but by now the question's sort of done all of its tricks, and this is a repeat of some of the ideas that you've already met. For example, once you know how big the shaded area is, well, that's on the right of this line, so you know that bit, if you care about that bit. So I suppose the question then is, as you move E around, how much more area from the big circle have you got as well as that shaded bit? So the shaded region is definitely on the right of that line. There's also a bit of S1, large circle over there. And once again, that's circle, straight line, stuff to one side of that. So we can just add on an extra term, and then I think we're just done. Because then we've got a total understanding of what's to the right of the line. It's kind of, we've already done that twice. Doing it a third time is fine. It'll be a mess to write it out, but not a kind of mathematically, not a challenge in a new way. Just, we're now really good at finding areas of regions. Sorry, I'm pausing a lot because I'm trying to make sure I have really understood what we're being asked to do. But I think if we find this area in terms of x, which is not too bad at all, right? It's x over 360 degrees or something, multiplied by pi r squared. That's for the sector, and then subtract from that 1/2 of sine x r squared for the triangle. You know, that thing again about sector minus triangle. If we do that, then we've got everything that's on the right hand side of the line, and we just need that to be half the total. I suppose I need a plan for total area, right? To say this is half the total area. I could work out the area on the other side, I suppose. That's just the rest of the circle. So maybe I'll just do pi r squared minus the green bit. For pi r squared minus the green bit for the stuff on the other side of the line. Because the other side of the line plus the green bit just makes a big circle. So you write down a horrible equation which we're not going to solve. Does chat want to say? I think I'd like chat's opinion, before we take a very short break at 6 o'clock. Chat's opinion. What do you say for the last part? Where, okay, we've done some hideous calculation to write down a horrible equation, which contains, at this stage, like 3 bits of circle minus triangle, 3 times, all of those together, and on the other side, the rest of the circle, and those are supposed to be equal, because they're equal areas. And the last part just says, explain why there is a unique solution X. Which at that stage, I think we're supposed to think geometrically again. We're supposed to think geometrically about what's going on. People in maths, computer science debating in chat whether they have to do this question or not. I think my argument would go something like, as x varies from a small number to a large number. So what's the smallest it can be? I was going to say 0, but then I realised that they've told me that E is on the larger arc. So E, the most extreme place I can put it, thinking about extreme places on the boundary of a circle again, the most extreme place I can put it is over here. We've already found an angle there. Was it 30 degrees? So as x varies from 30 degrees, which is definitely not equal areas. I'll check, I suppose, but that's definitely not equal areas. As it goes round, the area, have I got this right? Oh yeah, it's the area to the right of the line. So the area only increases as x goes round, until you've got almost everything on the same side of the line. So somewhere in between, there'll be a unique point where it kind of increased from not enough to too much, and it just increases. So it's somewhere in between. And I think that's good enough for this sort of maths. There's an idea about a sign change in there, right? That the difference can only change sign once because one of them just keeps getting larger while the other's getting smaller. So we can only cross 2 curves. We've got one going up and one coming down. We can cross somewhere in between, but only once. After that, they just keep changing away from each other. I've got a graph in my head, and it's not a very good graph. I don't think you should try and graph it, but the kind of graph that I've got in my head is like, as x changes, one of the areas increases, one of them decreases, and there's some crossover. But because it's only increasing and only decreasing functions for how much area there is, mumble, some sort of geometry understanding. There's something going on there. Okay. The work solution was completely algebraic, including the actual function. Oh my goodness. So maybe you could point at the function and say that function is definitely an increasing function. That doesn't sound very helpful, but hey, let's go back and check that later. Interesting. Neil says, I can either give Oxford an open out and also apply to 4 other unis. Yep, that's something you can do. The alternative is that you apply to 4 other unis, and at Oxford you choose a college. We're really just talking about a drop-down menu. When you apply to Oxford, there's a drop-down menu for campus where you can either select one of the colleges or you can choose open application. That is a specific thing about Oxford, and then either way you've got 4 other unis that you can apply to. None of this affects how many applications you're making, just whether you've specified a campus or not, to use the word that's on UCAS. I don't think I can talk about the algebra because you've got to. Well, the expression involves all of these factors of x and sine. Let's have a look at what it says on the web solution for this. So my resource, and this is maybe good if we don't talk about a question live on the stream as well. Just look at the solutions document. I guess I was technically responsible for this in 2018, wasn't I? Let's see, what does it say? 4. So horrible combination, right, of sign and values. And it's a fixed number on the right hand side. Why is that? Oh, because this has been phrased as 1/2 of the total. So rather than having an increasing function and a decreasing function for what's on each side, they phrased this as an increasing function and, by the way, the total is fixed, the same amount of area overall. That's not a nice number on the right hand side, but there you go. I'd say this is a geometric. I'd say it's a geometric argument though, because it does say the area of the larger segment is strictly increasing, and I don't think that's an argument algebraically about this combination of sine and x. It's tricky, right? Because there's sine and that's minus. There's a minus sign on x. Yeah, and it says differently said. So this would be a strictly algebraic thing if you argue that the left hand side is a strictly decreasing function. Don't love it, but we gave options on the word scheme there. Cool. Anonymous says, what's the last date I can apply to Oxford? The deadline for Oxford applications is the 15th of October, and you'd be alarmed how many people apply on the 15th of October. Please remember that after you press submit, it goes to your referee, and your referee needs to type their reference in and do your predicted grades, and they need to press submit, and all of that needs to happen before the deadline. So if you are going to leave it to the last day, then make sure you have coordinated with your referee. I think your referee will be quite unimpressed by this, but you know, depends how well you get on with your UCAS referee, I suppose. Did I know who my UCAS referee was? I'm not even certain I did. Is that a thing? I'm just joking around. No one's going to do this. No one's going to be like, oh yeah, I'm great pals with my UCAS referee, because then, well, your UCAS referee is not supposed to be one of your friends. Anyway, we're going to do a little bit more voting. But first, reminder, it's about 6 o'clock. If you've been looking at a screen for the last hour, please remember to look away from the screen. I'm going to drink some water. And based on some feedback, I'm going to mute myself while I do that. This is a vote for which past paper we're looking at next. I think we'll probably try a short question and then a long question. Right, okay, and it's a tie between 16 and 17 so far. Let's see how that goes. Rob says multiple choice questions harder. I think I know where you're coming from, because the multiple choice questions, often they've got one idea and it's quite hidden, whereas the long questions you get lots of chances to pick up on what's going on. Like in that question, it's really all about sector minus triangle. So it's really the same thing coming up lots of times. A little bit review for myself. What on earth did I do here? This was awful, wasn't it? What a weird step as well. I thought I knew sine 120 and I could multiply by root 3 over 1 and cancel some random factors of root 3 and root 2 in my head. That was too ambitious. I've done it a couple of times this evening. I'm sorry, I'm trying to skip too much working out. It always backfires though, because it goes wrong and then I have to do it anyway. And I've wasted time. Sorry about that. Anonymous is off to hockey training. Have fun at hockey training, anonymous person. Right, 2017 has, I'm saying, won this vote. So we're looking at 2017. And we are going to do a multiple choice question, I think. Oh, I need to reset that, don't I? Whoa. Reset and launch. Oh, love a bit of voting. Right, good. Let's have a look at what you could be voting for from 2017. There is a cubic. When's it got 2 distinct real stationary points? There's a cosine function thing, which you're not expected to differentiate. But wait, it says minimum. You can tell me about the minimum value of cosine. Or do you want the maximum value of cosine? I've seen both. Anyway, diagrams, transformations. I think we've talked about these two. We've got some integers such that with a constraint. Sorry, not a. Well, we've got some integers with a constraint. We'd like the maximum value. Diagram question, that one's a bit strange. Line question where it's about, it says larger, and that's part of the question. I think this question is about the remainder theorem, so I'm going to sort of eliminate it. I think I've left it in the vote, but I think this question uses the remainder theorem. Reminder on the remainder theorem, it's not on the syllabus anymore. It's a good question though. If you know about the remainder theorem, I think you will enjoy that question. If not, then I make no promises. I is lots of logarithms, but I feel like we've looked at this on the logarithms live stream. And J, lots of integrals, trick, you're not expected to calculate them. And this question is in radians in quite an annoying way. that makes it hard to translate the question into degrees. When this was set, we knew that everyone had seen radians by the time they took the test. We are no longer confident that we can assume that people have seen radians, so these days we ask questions in terms of degrees. I really don't know how we would do this question in terms of degrees, but there you go. Do I? I can kind of work it out. I don't know. G is winning the vote on this one. But G is kind of a tricky question, right? Let's talk about G. Let's talk about G, because there we go. Yes, Neil. A big part of my job is to make sure that we take the best candidates overall by making sure that people compare, and there's a little bit of swapping. Okay, so this question's got a kind of trick to it, where we need to work out a picture, I think. Because, oh my goodness, there's a disk, there's a line, the line goes through the point 1, minus 1, no, minus 1, 1, minus 1, 1. There are different things we could draw. I've realised we did this on a revision live stream, and I said something weird on the revision live stream. The key word in this question is larger, which unfortunately switches. So theta controls the angle here. When theta is 0, it is just y minus 1 equals 0. So y is 1, this horizontal line. And then as theta increases, you get different lines. And the side that's larger switches. So this is quite annoying. You have a theta, and that goes all the way around until you get to a line like this, which goes through the middle, which because it goes through the center, it divides the circle exactly in two, and then instead of it being larger on one side, it becomes larger on the other side, which is very annoying. It means that as theta changes, the area doesn't kind of smoothly change, it bounces. There's a particular value of theta where you think it's now going to get smaller and smaller, but because it's defined as the larger region, if you like, there are two regions. Let's sketch them. Two regions with areas like this, and A is the one that's larger, so the function A of theta does this. It takes the larger of the two, which switches between those two. So as one grows and the other shrinks, A of theta sort of bounces about which side you're talking about. That's annoying behaviour, and it means that the answer is 2, I'm afraid. But there are two values of theta which refer to the same line, by the way. Two values of theta which describe the same line, but with like a minus sign or a plus sign on both sides of this equation. So I think a popular choice is 1 value of theta, but the correct answer is 2 values of theta. So there's sort of almost a trick to this question, where you need to be careful to realise that once you convert it to a geometry problem, converting it back to an algebra problem isn't unique, that there are different values of theta which describe the same picture. For example, I'm going to use degrees, even though, never mind. 45 degrees and 135 degrees. No, 215 degrees. Ooh. Plus 180. So these values of theta describe the same equation. They have the same picture. The different values of theta. So actually, they have the same equation, just with a minus sign on both sides, because I've added 180 degrees, which puts a minus sign in the cos and in the sine. It has this kind of I suppose you could say this is a question about the fact that sine and cosine are periodic, and that adding 180 degrees flips the sign. Why don't you divide sine and cos and make it tan? Well, you could, but then that'll be a good way of realising this question is about tan, and tan has period 180 degrees, so anything that happens at a particular value of theta also happens at theta plus 180. And maybe that's a good way to realise that this thing they're describing doesn't just happen once, it happens twice in that range, because it happens a second time. Make it tan. Yeah. Okay, good. Of course, it could be the case that once you've made it tan, right, it's some function of tan theta or something, right? Because it's about the area, so it could be something complicated that then repeats. Or maybe not. Maybe not. You know, it could have multiple. It could achieve that maximum value multiple times. Not necessarily. And then there's somebody thinking, but no, the period is 180 because it could be like this, and then a wide one, and then like this, and then a wide. You don't really know if we haven't worked out the areas, and I don't want to. But it could be like this, so that the period is still that much, but it achieves its maximum twice, or do I mean 4 times? Because none of that happens. The answer is twice. For the reason that chat said, but I'm trying to get chat to think about. I'm trying to get Anonymous in chat to think about a slightly harder version, which would maybe catch them out with that argument. But none of this matters for multiple choice, right? Like if you get the right answer, you get the right answer. But like I have to try and challenge people's reasoning as well when we're on the stream. What does theta denote in the cos and sine? So when you read the question, it's just a parameter. It's just a variable, right? It doesn't have to have anything to do with angles. I mean, it's being put into cos and sine in here, so I'm thinking angle. But if you like, it's the angle above the x-axis. So as you change theta, the effect that you get is you get different lines. Let's Desmos it. We haven't Desmosed anything yet on this live stream. So the equation is, there we go, y minus 1 cos theta. Does Desmos know theta? Yeah, although I'm going to use t. No, I'm going to use a. I think Desmos has got particular feelings about theta. I will see if I can override them. Yeah, it's not happy. Okay, right, okay, we'll switch to A then. A is my favourite letter for everything. There we go. Equals x plus 1 sine theta. And then separately we have this disk x squared plus y squared like this. And the observation as you change theta is that this goes round and round and round. Whee! Which you can detect by spotting that you're looking at. I think some people in chat have rearranged this to be y minus 1 and x minus 1. They're kind of telling you about the gradient of a straight line. And the gradient of the straight line is tan theta. Think about rise and run, perhaps sine theta, cos theta. It all kind of fits together. All of these go through this point, which I know algebraically, because I know that if you put in x equals minus 1, you get 0, and if I put y equals 1 on the left, I get 0 as well, without thinking about theta. I like looking for things like that, so that you know, are there any points where I can say something no matter what theta is, and that makes y equals 1 jump out to me, because if y is 1, then I can say something about the left hand side without caring about theta. Like for all theta, it's 0, and I can say something similar, like a similar punchline on the right hand side. And now I've got this fact that if y is 1 and x is minus 1, then they're equal because they're both 0. So looking for special cases like that can reveal facts like there's a point that this line always goes through. The thing we want is that value or that value. Oh, let's get back. That value. Which is easy. You can do this turn, and a of theta will be the big area both times. The period 180 degree periodicity. Yeah, we've done this before, says Anonymous in chat. We've been here before. Okay, good. You voted. You voted. Right, cool. Long question time. I need to reset this one as well, don't I? Reset. Let's do a long question from 2017. What have we got this year? Can I remember? No. Something about lists. Something about shopping bags. Something about giving children sweets. Or something in the thumbnail about a horse. Do you like it when a question starts? A horse. A horse is attached by a rope to a corner of a square field of side length 1. Yes, I'm in. That's exactly how I want questions to start. Is it? A horse. Fun way to start a maths question. Something about sketching curves, which I feel like we might have done before. I feel like we might have said things about this before, and a question about some equations where we find values. Aha! Do we find the values or do we not find the values? Let's find out. Anonymous says, James, what branch of maths do you teach? And hey, I do the applied maths for first year at New College. I do some of the applied maths, most of the applied maths, and I do some stuff in applied maths in second year in New College. But in the department, I do essentially pure maths because I do the Introduction to University Maths course, which is on this YouTube channel. So I teach the 19 videos before this one on this channel. I'm very excited. The course is now live, so I've got my 19 videos out. And then in tutorials, I get to do the other side of the world, which is applied maths. I think question 2 is winning this poll. I think question 2 is winning this poll. I don't know why I'm talking about IUM so much. IUM is like really not relevant to this. Somebody's put a comment on one of the videos to say, does this help with math? And the answer is like, really no. Like, in some sense, Introduction to University Mathematics is a lot of the stuff that we don't assume you know on the mat, but then at university we would like to make sure everybody knows it. So it's like the other side. Like, once people have got through it, okay, now we need to check that and teach people new stuff as well to set them up for university. So it's kind of almost exactly stuff that I'm worried you might not have seen, which would make terrible math questions because I'm worried you might not have seen it, but will make great introductory material because I'm worried you might not have seen it. So it's precisely that stuff that I'm a bit stressed about, like some notation that people might or might not have seen. Like exactly things that would make bad math questions, but good introductory material. Oh well, there we go. The backwards. What's the backwards question? 2018-3 part 2. Is it okay to write M is, and then they've written that, and then not expand G of X? I can't remember. I think you probably should write down what G of X is. You know it from the question. I think you probably get at least 1 mark for doing that. Yeah, it seems fine. I'm not going to mark all of that. Has the difficulty? Right, okay, good. Okay, I think 2's one this way. Quick zoom for question image quality. Only thing for... It's because I've loaded so many images onto the same board. It's trying not to load all of them into my poor computer's RAM. And as we do more fast papers, my poor computer has to load more of them into... How are you doing over there? It's just put the fans on. Okay, right. Question 2 is for all applicants in 2017. Fun. The question says, there is a unique real number that satisfies this equation. You were not asked to prove this. Hooray! Great news. Part 1, show that alpha is between 0 and 1. Oh gosh, right, I should probably try and sketch this. 2 ways you could go. You could subtract 1 from both sides, or you could sketch both this and this, or alpha on the right hand side would be fine, to kind of sketch x cubed plus x squared and 1 at the same time. Try and work out what's going on there, or something where you draw the same picture but translated down by 1 unit to talk about what's going on there. Either way, I think your argument is going to be plus. Either way, I think your argument is going to be there's a function that's increasing and it can only be 1 once. Similar idea to that monotonic area question we were talking about before the break, right? Increasing only 1 once. A bit like my age, isn't it? My age is only increasing and it's only been the number 1 once. Thank you. Yeah, alpha squared. Yes. It should be plus. Oh, anonymous. Is the switch to 27 questions a very big one in terms of question style? No. Not really. We were already asking questions where you explain things. And there's lots of long questions that we couldn't do anymore with the new format, but there's not as many long questions. So it's not been that bad behind the scenes. Okay. So we're going to sketch this. We're going to do some sort of argument like you're only one once. The new catchphrase of a generation. You're only born once. You can't go back. What if I substitute 1 and 0 to get 2 and 0 and say, yes, it must cross in between. There's a sign change. Yeah, love it. Good. You can do that. That is good. Show that, and then we've got this horrendous thing to show. Oh my goodness. Alpha to the 4 on the left is equal to, and then some stuff that I vaguely, it looks thematically similar to what we've already got, but not the same stuff. How on earth am I going to work out alpha to the 4? I don't know alpha. So, question for chat perhaps. Chat anonymous says, favourite Matt question so far? Why are we thinking about quotient rings? Okay, right. Yes, it says don't prove it. So, in some sense, maybe this is a sort of trap for people who have learnt some pure maths but not learnt some other stuff. How did you get part 1? So, on the left we've got a polynomial, and polynomials are, so increases when, if you put 0 in the left hand side, you get 0, it goes through the origin. If you put 1 in the left hand side, you get 2. So join the dots in between somewhere. This polynomial has to go through the value 1, somewhere in between. And some people in chat are saying continuous, and some people in chat are saying sign change. And you don't need any fancy words for this, I think, at this level. We're not expecting people to know what a continuous function is. It's not on the syllabus, but we are expecting this kind of idea that when you draw a graph, you draw it and you join the values together, right? So somewhere in between, it's going to be a value somewhere in between. Multiply the equation by alpha. That's a great idea. Yeah, so to get from here to here, a bit like spot the difference or something. I might multiply by alpha, and multiplying by alpha, I know that I'll get alpha to the 4. So I'm currently thinking, hooray, alpha to the 4, I wanted one of those. And then everything else is kind of consequences. So I'm less keen on these. I guess if I really think about it, this alpha on the right hand side, that can stay, that's all right. But this alpha cubed here, I didn't really want one of these. So next step is going to be to try and get rid of alpha cubed. How can I get rid of that? I have alpha to the 4 is alpha minus alpha cubed. And if I really play spot the difference on this, then I can get quite precisely what I want, right? I have alpha, I have minus alpha cubed, and I want somehow these two terms. So I need something that relates alpha cubed to these two terms over here. What's going on? Yeah, so then next step is realize that, oh, I don't need to know the value of alpha cubed, or the value of alpha, or the value of alpha to the 4, or whatever. I should use the fact we've already got. The fact that we've already got tells me that alpha cubed is, using this fact up here again, is 1 minus alpha squared. Yeah. Ooh, okay, could you take a factor of alpha out? Different method in chat coming through. Different method in chat coming through. Which is then if I multiply out the minus sign. Let me finish this. There we go. Okay. Phew, great. Now I'm just generically happy. Good. I like this because it requires a bit of a leap of faith, perhaps. I've got this phrase maths vision that I'm sort of working on, which is how far ahead can you see about what's going to happen through the algebra? Probably not all the way through a calculation like this. But maybe it's a bit, if I multiply by alpha, then I know that I will get alpha to the 4. And then it'll be a fight to work out what else happens. Sorry, a fight to deal with the consequences. Maybe your maths vision, how far ahead you can see, is if I multiply by alpha, then I'll get alpha to the 4 and some smaller powers of alpha, or some other powers of alpha, and I'll be able to deal with those down the road. And maybe your maths vision is if I multiply by alpha, I will get alpha cubed, I will eliminate it using this equation. Maybe you can see that you're going to take these steps all the way ahead. It's not very visual, is it, if I do this? Because that's like, I Actually, do I do it sideways? To be like, how far ahead can you see? Oh yeah, sideways is better. There we go. How far ahead can you see for what's going to happen? And I'm not saying you have to see all of that, visualize it. Oh my goodness. See the algebra. I'm trying to encourage people to guess ahead for what might be about to happen. Anyway, we've got some more functions coming up underneath here. It's great fun. You can see the equation allows you to reduce. Okay, so you already spotted this alpha cubed relates to some quadratic, which is the point of this question as well. In a similar manner, each of these expressions down here is secretly equal to some quadratic expression like this. So what I expected for this part of the question, of course, having done alpha to the 4, is maybe alpha to the 5. And maybe we should talk about that. What would you do for alpha to the 5? But you'd be all right. I think there's a past question that's a bit like that, where you then work out alpha to the 5 by doing the same thing again. Right, here we are. So part 2 we found -1, 1, 1 for the coefficients. Yes, we did. You may assume in each case that the quadratic expression is unique. Okay, that's nice. So then the puzzle here is to work out, well, how can I make things like 1 over alpha, alpha to the -1, from what I already had? We know how to make alpha to the 4. How do I make alpha 1 over alpha? And in each case, we'll need something clever to, well, I suppose something clever to realise how we can make this out of things we've already got. It's a bit more like chemistry than maths, isn't it? We've got some reagents and we need to mix them together in the right order to get the thing we're aiming for at the end. Part E, synthesize aspirin or something. I remember chemistry. How much does referee's reference matter? A bit. I mean, we'll look at it. It's often got important information on it. For some people, it will tell us about their education in a way that, you know, if their school doesn't really do further maths, or if their teacher is not really a maths teacher, maybe they'll mention that. That's sometimes helpful to know. Usually the teacher's reference talks mostly about the candidate and tells us the candidate's really great, which is lovely to read. Not super helpful for choosing between candidates because, yeah, we're not looking at who your reference is by. Mostly they're written by teachers in schools. It's not a question of getting someone famous to write your reference for you. Please don't bother any famous people trying to get them to write your reference for you, unless that's an appropriate thing to do because they can comment on your academic ability and have time to do so. You don't need to have a particular person's reference. It's just something that can comment on you and your education. Right. I don't really understand what the question is saying. The question is saying that for each of these, you can work out a quadratic expression, and they define a quadratic expression like this, right? Not having alpha cubed in. They have to say that, otherwise I'm just going to write down that it's this, or you know, like this minus this, or something really silly. They have to say what I'm aiming for. I'm aiming for an expression that just involves number plus a multiple of alpha and a multiple of alpha squared. In chat, I saw Rosie say, you can sort of replace this one, or if you like, you can divide the initial expression by alpha to get alpha squared plus alpha, which is good because that's in the right format. 1 times alpha plus 1, just to be explicitly clear about it, right? Like 1 alpha squared, none. It's kind of a bit like saying you can build whatever you like out of these options using just these building blocks. But secretly that expression looks weirder, but oh, it's the same. It's like this. Will math questions help with a PAT? I guess so. They've got maths questions on there as well, haven't they? I think they do. I think they've got maths questions and physics questions. I can't see why it wouldn't help. I mean, I also talk a lot of nonsense about precise things about how the mat is formatted, so you should probably also check how the PAT is formatted, but no reason to say this won't help. I mean, I'm quite open-minded about just solving tricky problems. It's probably good for you in general. It's kind of why I do a lot of this. Anyway, never mind. Right, okay, I like that. Let's talk about this infinite sum, at which point we need some more. We need some more ideas, don't we? We've got 3 of these, although spoilers, the last 2 are the same. The last 2 are the same because this is, I guess it's something about binary or something, but once you multiply out a few of these, you spot that it's just all of the powers of alpha. So that times this is the same, but then plus alpha to the 4 times all of those. So after a while, you notice that as you multiply the brackets, you get more and more of these alpha terms. In just the coefficients are all 1, so it's just the same thing as having all of them together. So these are the same. Geometric sum, these are the same as each other. Favorite ever a math problem? Yeah. So we could, what can we do for B? We could spot that this is a geometric sum. First term 1, common term alpha, minus alpha, thank you anonymous, you saved me a minus sign there. We could do that, at which point we've got to find really some way to simplify 1 plus alpha. We're trying to turn this not into 1 over a linear expression like that, we're trying to get a quadratic expression. We're told that there are some integers a, b and c. So what can we do? Where can we get a 1 plus alpha out of this? I'm looking back up the top because, well, this is a kind of ground truth. It's the first thing that we were told about alpha. And I'm trying to find a 1 plus alpha. Is this silly? But I can kind of see one in here, right? I think I can see one in here. That's alpha squared. Factorising the left-hand side right at the top. I think. So I think this is just alpha squared. Nice. One more. Reducing each term to a quadratic and telescoping. Ooh, that sounds clever. Each term to a quadratic. What do they mean by each term? Oh my goodness, they know 1, they know minus alpha, they know first bit's quadratic, they know alpha cubed is a quadratic, they know alpha to the 4 is a quadratic, and so on. And then squash it all together. Oh my goodness. That sounds quite tricky. Yeah. And then for 1 minus alpha, I think we're going to do what Rob says. I'm going to use 1 minus alpha. 1 plus alpha is 1 minus alpha squared. It's alpha cubed. So I think we're good. I can't really be correct about that alpha squared thing, can I? On the right? I think I've made a mistake and no one's told me off yet. But take the original expression, alpha squared, alpha plus 1. I remember this question being much harder than this. Am I thinking of a different question? I think the question I'm thinking of had the number 2 in it, and it's on one of the revision sheets. And that's really throwing me, because I'm thinking of the revision sheet question I did a couple of months ago, and not this one. There we go, okay. Yeah, so just alpha squared? Can my principal write my reference even though she's not my maths teacher? Yep. There are almost no rules on this. I mean, they're not allowed to be a family member or a close friend. They should know you academically. That's about it. There's some guidance on the UCAS website if you would like the official take on the rules on this. I'm sure UCAS will tell you there are lots of rules on who can be your UCAS referee, but it's definitely not as restrictive as they must be a maths teacher for a maths application. Okay. Yeah, there was like a sequence. It was quite hard. This one's not hard at all, is it? This one's fine, right? That's right, it's reductive of me to say not hard at all. But, well, aren't we going to get something like, here we want 1 over 1 minus alpha, and we know that 1 minus alpha, 1 plus alpha is alpha cubed. So isn't this, if I flip it over, aha, 1 over alpha cubed, maybe this is a silly way to do it, but I'm going to carry on. I've convinced myself that this is alpha squared, by the way. So then, times alpha squared, let's put the alpha squared in, because this 1 over 1 plus alpha, it doesn't look like an alpha squared, but it's equal to alpha squared. It's 1 over alpha cubed. Okay, so I think I've done something daft here, because I now need to work out 1 over alpha to the 5, which I can do, but it's going to take me ages. Yeah, I can do that, can't I? But it's going to take me ages. So I'm open to the idea that there's a better strategy for this. Maybe chat can help me out, or maybe I could just work out 1 over alpha to the 5. I think I can work it out because oh gosh, I love this, but a shortcut to work this out. So I could do it the slow way, which is something like keep dividing this by alpha. It works for 1 over alpha. Let's keep going. So you divide it by alpha, you get 1 plus alpha. You divide it by alpha again, you get that involves 1 over alpha, but we know that one, so it kind of repeats around again. Keep going, but better strategy. We have this fact about alpha squared. So using this, alpha to the minus 2 is 1 plus alpha, I think. So alpha to the minus 4 is 1 plus 2 alpha plus alpha squared, squaring it. And then alpha to the minus 5 is, I do get a little bit of 1 over alpha, but I already know that one. It's alpha plus alpha squared. So using a previous part here. Yeah, it doesn't seem too bad. Okay. So I get something like 2 plus 2 alpha plus alpha squared. Feels familiar enough. Ooh, someone in chat says difference of 2 cubes, and now you've got my interest. You always have my interest, chat, but difference of 2 cubes. Where are the 2 cubes? Oh, there's an alpha cubed and a 1. Oh, that sounds clever. That sounds clever. Does difference of 2 cubes involve 1 minus alpha? It does, doesn't it? Oh, that's very good. That's very good indeed. Right, okay, so difference of 2 cubes. Let's see if I can take that quite concise chat message. Let's put it top. That quite concise chat message. I think they're telling me to do 1 minus alpha equals alpha squared, and then remember that I can factorize that sort of polynomial as well to get this. And then, so big if true, 1 plus alpha squared over alpha squared is 1 over 1 minus alpha, the thing I'm aiming for. I've still got to work out this, right? You know, so I've got to work out 1 over alpha, which I know from a previous part. And I've got to work out 1 over alpha squared. I guess I could divide that by alpha. Oops. Oops, oops, oops. And then I get 2 plus 2 alpha plus alpha squared. I like that a lot. I still had to work out 1 over alpha squared, but that's not too bad. Right, thank you. Difference of 2 cubes will involve the 1 minus alpha and some quadratic term, which becomes a little bit of a pain because of the alpha squared on the right hand side. But I like that a lot. This is a fun game, isn't it? I wonder what else we can build. What other functions can we convert secretly into these hidden quadratics, I guess you could call them. Things that you can express in terms of alpha. This is a whole game, which somebody in chat mentioned, but this idea that you look at the things generated by a particular solution to a particular equation, and this gives you a kind of extended number system, but maybe not that extended. If things keep turning out to be secretly just a quadratic, then you didn't add that much stuff, did you? Because you might think that you've added all of this like infinite sums and weird like 1 over alphas, but they're all just quadratics. It wasn't that big an extension anyway, was it? How did you do difference to your cubes? Rob, you're going to love it. It's going to be great. You know this fact, right? So this polynomial, you can factorize it because when x is 1, that's a root of the polynomial. So factor theorem says it's got x minus 1. And then I've done this a few times, so I can kind of remember what this is. But you could work this out by polynomial division or something. That it's x squared plus x plus 1. So that's one fact you can have. That the difference of these 2 cubes factorizes like this. But in general, the difference of 2 cubes factorizes like this. Oh, call back to the s squared st s over t thing. The way you get between these 2 facts is you set x equal to a over b and you multiply up. Or said differently, when you see a squared, ab and b squared all sitting next to each other, you think, what would happen if I divided that by b squared? And what would happen if I divided this bracket by b? And they're both like single letters. So what if I divided them by b? Well, I'd be dividing the whole thing by b cubed, and then you get back to that. So that's like the S over T thing from the start of the live stream tonight. These things are kind of related. Anyway, Rob asks difference of two cubes. There you go. There was a math question about this back in 2015. Zoom out. There it is. Oh, I wish I could do that as like a superpower. Whenever someone mentions a math question, I zoom out, I know where it is, I zoom back in again. That would be amazing, wouldn't it? Yeah, so this question extended that idea to the difference of two n+1th powers, spoilers for part 1, and then makes you do tricks with it for the next 3 parts. We're going to zoom in on a very particular question. Come with me on a journey, because I saw someone request a very particular question in chat, and it's from 2016, which I haven't looked at yet. We've got 15 minutes. They wanted the end of question 3. That's 4. It doesn't always work, does it? Oh, right, okay. So question 3, we're going to try and catch up with where they've got to. And the request is that we kind of look at the last part. Zoom for focus. Okay. Okay, the chat is going off for space just for a second. There we go. Okay, so we're going to fix real number alpha, and we say that function is bilateral if it does this. F of x is f of 2 alpha minus x for all x. So that's a good fact. So this function is quadratic with minimum at a turning point at alpha is bilateral. That's sort of what's going on, but never mind. This function is not bilateral because values of the function for large values of x are not the same as values of the function for very small x, and many other reasons as well. It just doesn't do the thing that it's supposed to do if it's going to be bilateral. This thing here doesn't do that. Show that if n is a non-negative integer and a and b are any real numbers, then, well, this is just a separate fact about polynomials, right? But this is a fact about reflecting areas. I think if you know about substitutions, you can rewrite that using a substitution. But in general, what we're looking at here is some sort of area question where we've got a and b. I'm going to draw them over here, a and b, and we're looking at this area. B to a is, oh gosh, it's going in the opposite direction. This is a bit of a nasty question. I was hoping we could just argue geometrically to say, oh, it's being reflected, but that's not obvious at all, is it? Wait, these are polynomials. I can just integrate them. You just go for it, right? Nobody read this and thought about areas, did they? You can just integrate x to the n. I didn't spot that it was x to the n. I think I said polynomial, but I didn't think I know how to integrate polynomials. Don't listen to me. Yes, listen to Rosie in chat who says you could also just evaluate both sides. Great question. Okay. Hence show that if f of f is a polynomial, then you do this. Suppose that f is any add them up, right? You can add together integrals of different functions, it's allowed. Suppose that f is any bilateral function, and now it does the thing I was expecting it to say. By considering the area under the graph, explain why, and then you do this. Which is, let's draw a big picture. But I need to draw it so that on the right, so I've drawn that parabola from a previous part, x minus alpha all squared. And the question asks me to integrate from alpha to t, and separately to consider what would happen if I integrate from 2 alpha minus t, which I think is over here, up to alpha, and these distances are the same, they're both t minus alpha. So we're doing the same distance, and the values that we get are the same because the function is bilateral, so we're adding up lots of the same values. And in this case, we're integrating in the kind of sensible direction in both cases. T is greater than or equal to alpha, so we're all fine. Good, I'm doing this one super fast because I'm trying to get to part 6 immediately, which is the thing that was requested in chat. So here we are. Okay. If f is a function, here we go then. we write g of t to be that integral that we just had. So this thing is now g of t. I think this is the part they requested, but maybe they want the next part and I misread it. So g of t is defined to be that integral. What's this then? No, I suppose this is the part they asked for, isn't it? So this is the part where it's a polynomial, so we can use part 4, and it's bilateral, so we can use part 5. So we've got lots of tools now. We have integral from this. Because it's a polynomial, we know that we're allowed to bring out that minus sign. I realise now, I said some stuff about integration by substitution, and that is not the idea of the question. The idea of the question is not that you do integration by substitution. I'm very carefully proving, I think, by thinking about areas. Anyway, I enjoyed halfway through part 5. Halfway through part 5, we had some idea that f is a bilateral function that's got a definition. It means that values, what does it mean? Well, it means that f of, up here is defined, f of x is f of 2 alpha minus x. Which is kind of cool. The thing I'm claiming, and I haven't actually done the algebra on the screen to justify this, is that this means that the values on one side of alpha are the same as the values on the other side of alpha. I haven't done anything to justify that, but I suppose the question has forced me to think about distances like t minus alpha and alpha minus 2 alpha minus t, at which point I've kind of realised that you can rewrite this as alpha plus and then alpha minus x. Is that fair? No, that's not good. I don't like that. Oh yeah, so I guess x here, I'm kind of interested in what's going on at the endpoints, like t, or I guess somewhere in between as well, but sort of f of alpha plus something, distance d, is equal to 2 alpha minus that much, which is f of alpha minus d. So there's kind of hiding in here is a kind of symmetry, which says that f of alpha plus d must be f of alpha minus d. And the question is really trying to make me think about going to the right of alpha or to the left of alpha, with this weird quantity 2 alpha minus t, which eventually I realise is this kind of symmetry. It's a reflection in the line x equals alpha. You get the same values on the right of that line as you do on the left at equal distances away from that. That kind of justifies these integrals being the same, because when you're adding up the same values as you read away from alpha. Okay, good. Show that, and then there's this thing about g. So part 6, we have 2 facts now, because we've proved a fact about bilateral functions and we've proved a fact about polynomial functions to do with integration. And we get this minus sign for switching the limits, which is using part 4. And then we get to recognise that this is g Have I used the fact it's bilateral? I don't think I have. Oh no, this thing on the right hand side, not yet. This integral that was in part 5, here it is. This integral I've copied out. This is minus g of 2 alpha minus t, just because that's what g is. So I'm combining together the definition of g with the stuff in part 5. But part 5 also has an equal sign in it. Part 5 says it's equal to, and that thing is just g of t on the left. So part 5 says equals between those two things. So the left hand side really is just g of t, and the right hand side you have to think about that minus sign, because we're now told it's polynomial. So you think about that minus sign to get the minus sign in front of g of 2 alpha minus t. Fun. And then part 7 at the end, suppose that f is a bilateral polynomial such that g is also bilateral, and this would be weird, because this would be that g of t would have to be g of 2 alpha minus t. Yikes. So can you spot why that means that stuff is 0? Well, on the one hand, we just showed in part 6 that there's a minus sign, and then in part 7 if G is bilateral, then there isn't a minus sign. Suspicious. Yeah. The solution bank does it for, the web solution does it with T positive and T negative. Why? Why would it do that? Oh, fair. Yeah, fair. Maybe I've been too hasty. So I said part 5, but part 5 has some terms and conditions in. Part 5 only says that this holds if T is greater than or equal to alpha. That's annoying. So I think I need a separate case, which for me is T less than or equal to alpha. For T less than or equal to alpha, I'd need to, like, the same thing's true. The same equation is just true, so I don't think it's meaningful to split the cases apart. I guess they're not areas anymore, they're signed areas. Yeah, Rosie's got part 7 there as well, in chat. Cool, okay. So up to me skipping most of the question. The structure here, which is maybe the takeaway, whether or not you wanted this question, I'm aware I've stopped doing voting for this one only. The takeaway is maybe that this question, more than the other ones we've looked at, has got a structure that builds on previous parts. That you prove something about polynomials, you prove something about bilateral functions, and then you're asked about bilateral polynomials. Right? You get to use both facts, and more than the others, it builds on the previous parts, I think. There's also a very good question in chat to ask, can you use integration by substitution? And I don't know the answer. I think you probably shouldn't if you can avoid it, because integration by substitution is not on the syllabus. And I think ideally the question would say, don't use integration by substitution. And my reason for saying that is I think that integration by substitution makes the question too easy, and I think the question should stop you from doing it the easy way. And that's not really fair on you. If you know about integration by substitution, then you're not demonstrating that you can do the question the intended way. You're just demonstrating that you know a fact that makes it easier. And this is kind of what I think whenever someone says, can I just use a theorem? The answer is kind of, don't you want to show that you can? The point of this is that you're demonstrating that you can do maths, right? Not necessarily that you've memorized the maths or that you've seen maths before, just that you can solve maths. Don't you want to do the thing to demonstrate that? Anyway, never mind. We had a question near the start of the show, I don't know if they're still here, about can you just use a theorem or use a technique? And like, sometimes it's arguable that you could just write down a thing, right? Well, what do I do? If someone does this question and just says substitution, off we go. In some sense, that tells me they've seen substitution. Probably I should give them lots of marks, but I'm not sure it's the strength of the question. These are the things you think about when you're writing questions, right? Are we making it so that it's fair on the people who haven't seen whatever topic you name that's not on the syllabus, and is it also fair on the people who have seen it to make sure that they're still doing the thing they're supposed to be doing, which is demonstrating they're solving stuff? Yeah, I say, what does 4 look like? 4 doesn't even have any T's in it. Now I'm really confused. What does 4 look like with T negative? No, it doesn't have any. What questions from the old format are most similar to the new long questions? It's a tricky question, right? Because essentially that question is, which single past question should I look at to get something that's similar? So you can see the long questions from 2024 are on the website. So you can see those ones. You can't see the long questions from this year because they're secret. So I don't quite know what your question, what you're hoping for. If you're hoping that I go through and pick out the past question which is the most similar to the secret question that you might do in 2025, then I think you're going to be disappointed. Okay. Yeah, I'm not even going to tell you the question number of the past question that's most similar to the questions in this year. Oh dear. Okay. Now part 6. Right. Okay. Part 6 for T negative. So what's going on? Time? Oh yeah. Okay. We'll go over slightly. I've been asked to think about what's going on with T negative. So G is defined. So there's nothing wrong with G if T is negative. T could be negative. It says all T here. T could be negative in G. And then maybe I'm supposed to say that this thing over here, no, it's still G. It's still G. It really is G. But we've only explained this. Is alpha positive? I'd like it if alpha was positive. I don't see why it would be though. I still don't see, I'm being silly I think, but I still don't see what's special about T being negative. I think it's a me thing where I kind of believe that that fact will hold when T is less than alpha as well. It just does hold when T is less than alpha. I suppose we haven't shown it, but I also don't think I need to. Yep, sorry, I don't even know what's special about 0. Does it really say T is 0? There's nothing special about 0. It might say alpha. Okay, we're going to check. I've been told that I should look at, what is this, 16.3? There's nothing special about the value 0 for this question, right? Oh, it says, okay, it says, but if T is less than or equal to alpha. Okay, so if T is less than or equal to alpha, I kind of agree that we can't use part 5 because technically part 5 says that T has to be greater than or equal to alpha. And the solution online very properly says if T is less than or equal to alpha, then we have a problem. We can't use part 5. But luckily, the same fact is true when T is less than or equal to alpha. So you can prove it if you like by switching. And they do a switch to talk about U equals 2 alpha minus T. And then say that solves this. So I thought it was weird. The web solution splits out that case separately, but then says that it just follows almost immediately from the thing we've done. I reckon they might have given a mark for that in 2017. And I think I would have got 2 out of 3 because I don't think I really, well, you know, part 5 they're talking about signed areas quite a lot. Your mileage may vary. Okay, yeah, the solution bank splits it into T greater than alpha, T less than alpha, not positive or negative. Yeah, okay, that confused me. And I kind of accept it because part 5, we only have this fact. Luckily, a very similar fact is true when T is less than alpha, but I don't totally understand why they split it. I don't totally understand why the question says that. Possibly they're worried about signed areas and what people will write for that part of the question. I didn't write anything, so I suppose at the moment I've got no marks. There we go then. Okay, we're out of time, I think. Thanks for joining in. Thanks for all your voting. And thanks for the recommendation that I should go and look at the 2023B question I. The solution that I wrote is unhelpful. So that's on my to-do list. The person asking what matters the most, I think is telling that we do a MAT live stream. We don't run a personal statement live stream. You can make your own inferences from that. We will separately do an interview live stream after the MAT's happened. You can make your own inferences from that, I guess. Right, okay, but I've got to go. We will see you in 166 hours for another episode of the Oxford Online... No, wrong phrase. Rewind. Oh, I'm ready for the Maths Club. That'll come back in January. We'll see you in 166 hours for another episode of the Oxford MAT Livestream. But until then, have a good evening, have a good weekend, have a good week. See you on Thursday. Bye. Maths Club.